Hi everyone, welcome to How We Did It Jamaica, and this is part 2 of the two-part series where I'm building my solar generator. So let's just break down the agenda for this video. I want to talk about why I built this solar generator, a little bit about the pros and cons. I want to complete the installation of the solar panels and the inverter, and I want to talk about the impact on my electricity bill as well as the cost of components. So let's talk a bit about why I built my solar generator. So the main reason was to reduce the electricity bill cost, and this would be done by powering the refrigerator. And now in my household, the refrigerator uses the most electricity on a monthly basis, and it uses about 108 kilowatt hours a month. The other reason was I needed to have a source of power during grid outages, because who doesn't like to have a backup source of power when there's a storm or there's just a general outage of the grid. Let's move on to pros and cons. Now, the biggest benefit to having a solar generator is it helps to reduce your electricity bill. It also provides you with a backup source of power whenever there's an outage. The downsides to this is it normally presents you with a higher upfront costs whenever you're trying to build a PV system, and there's also that issue of having little to no production of electricity whenever you have a lack of sunlight, that being overcast conditions or during the night. Before we get into the video, here's my disclaimer again. I'm not an electrician, and this is just a DIY project. Picking up from the last video, we completed our battery build, a build of 8 cells wired in series. We had attached our BMS and we were getting power. And even though I didn't show you, I had attached the inverter, and this is what it now looks like. Also attached the circuit breakers and connected the battery to the circuit breaker between the battery and the inverter. So this is what it looks like. Almost done, but still have a few more things to complete, like attaching the wires from the inverter to the output, the circuit breaker output. So here's how I did it. I'm going to show you how I will crimp these ferrule ends onto the wires so I can connect the inverter to those two circuit breakers you see right there beside each other with the outlets at the bottom. So you insert the ferrule end onto your stripped wire, you get your ferrule crimper, squeeze as hard as you can, and there you go. I think that wasn't done properly, but for now it works. And so these tools, you can get them on Amazon, AliExpress, wherever. Always try to get some quality tools so they can last you a long time as well as do the job properly. And here I'm attaching the other end. Just slide the ferrule end onto it and slide the crimping tool over that ferrule end, and then squeeze as hard as you can. And these wires, I think they are like 10 gauge wires. So a 10 gauge or 8 gauge, can't remember exactly. But if you're in doubt, just check the specs of your inverter, and that should guide you accordingly. Every inverter carries different specification for the type of wires you will need, so check the specs of your inverter. Here you can see I powered the inverter on with it being connected to the battery. Also completed those crimps and attached the output the circuit breakers on the output side. There you can see those circuit breakers for the grid input. Those flimsy wires, I think I need to replace those because the amount of power that goes, the amount of amps that goes through the input side, it's a lot more than these wires can handle. So I'll go ahead and replace those in the next part of the video. Now you can see the circuit breaker for the battery. Those I think are 6 gauge wires or 4 gauge wires, don't remember, but just check the specifications of your inverter, the requirements of your inverter. They'll tell you exactly the size wires you need to connect your inverter to any battery. So always remember, check the requirements, not the specifications. Yeah, specifications as well, but check the requirements of your inverter. Here you can see I'm about to plug in the inverter into the grid to see if I can charge it for the first time. No accidents there, no explosions. However, these wires are way too small. Let's flip it on and see if it's charging. And as you can see, that grid icon comes up. We're charging at 110 volts. You can see that the inverter shows the same voltage, and you can see that voltage, that electricity heading into the battery. The battery is currently at 26.8 volts. You can change by pressing the screen. It will show you the amperage versus the voltage. Now that charging is complete, let's take a look and see. By the way, that indicator light in red means that it's on battery power. So we charge up to 84%, and you can see that circuit breaker for the output is on, and we're pulling 145 watts of electricity. And I think at the time I was powering a 40-inch television just to test it out. Now, as I mentioned, I needed to upgrade the wire that I used to connect it to the grid. I upgraded it to a 10 gauge wire, which can carry a lot more current. You can see there it's a lot thicker than the flimsy wires that you saw earlier in the video. So let's move on to the Wi-Fi adapter. I think I had to purchase this separately, but they're like generic Wi-Fi adapters that can use for multiple different type of inverters. So all you need to do is screw on that antenna right there, plug that wired connection into the Wi-Fi adapter, and then you plug that into the inverter. There's a slot there that's like a RJ45 port that you plug into the bottom of the inverter. So you plug that end that looks like a VGA cable end. For my IT folks, looks like a VGA connector. You plug the RJ45 end into the bottom of the inverter. There you can see a port saying Wi-Fi right beside the BMS port. Those are RJ45 ports. So you plug that in, And that I basically placed it at the top of that piece of plywood. I'm going to screw that in right there. And if you can take a look at the BMS screen, you can see that we're at 92% because I did a little more charging during this time. So it's now connected and screwed down, and you can see the light on the Wi-Fi adapter. And there's an app for this. I'll walk you guys through how it looks later in the video. Just showing you how the setup looks. You can see the other tools there. This is the manual for the Wi-Fi adapter, and it will show you how to set up the app. Now for my panels, you can see that I'm using solar rays or Solary. It's a 580 watt panel. You can see that the voltage at max power is around 42.59 volts, and the current at max power is 13.62 amps. Now I'm using 3 of these solar panels, so at max efficiency I should be getting 1700 watts. Up and running again. Now at this time I had moved from where I previously lived, but now you can see the solar panels connected to an inverter, and it's outputting 128 volts. Now that's lower than max efficiency, but for the month of December that's quite fine. You can see here that the battery is charging pretty well. So let's move on to the use of the app. So this is one of those generic data loggers. Basically you'll be able to see how the electricity is flowing in your system. You can see that the battery is currently powering the loads in the house. Well, the load, which is the refrigerator. If you move to the charts, you can see your power generation as well as your load, whatever power the load is drawing from your system. You can view this on a daily basis, monthly, or even annually, and it can give you a total of the amount of power you've generated or consumed since you installed the system. So it's quite fine for a small power generator like this, solar generator like this. You will also be able to change the settings of the inverter within the app, and you can also view logs for events that occurred on the inverter, so like faults, alarms, and so on. Now on to my favorite part of the video, the JPS app. On your JPS app you can click on view more, and then you can go to usage, and you can see a breakdown of your usage, whether month by month, day by day, and I think annually as well. You can see my usage. Here's a weekly breakdown of the usage, and you can see that just by powering my refrigerator with this solar power generator, I was able to reduce my light bill by a half, so a 50% reduction in my light bill. So now you can see the power, pardon the pun, of this solar generator. So let's now talk about the cost of the components. Now on screen is a breakdown of the cost of each major component that I used to build this solar generator. I provided the cost in US dollars because that's what I paid. All of these components were purchased either on AliExpress or Alibaba. I used AliExpress and Alibaba because those were the cheapest prices I could find. so please bear that in mind. Another thing to note is that these prices don't include the cost of shipping. So if you live in Jamaica or you visit Jamaica frequently, you'll know that we tend to use a lot of freight forwarding companies that move packages from the US to Jamaica. So if you're going to use a freight forwarding company, take note of the rate of the freight forwarding company. That's the cost they charge for each individual pound or a pallet, so you'll know the final price that you'll pay for these items. Another important thing to know is that Jamaica doesn't charge duties on solar inverters or the batteries being used in PV systems. So you should bear that in mind when you're shipping your items from the US or from China to Jamaica. So to further explain the cost of the components, you can see the inverter and the Wi-Fi module there. I paid approximately 250 US dollars for both, and then at the current exchange rate, that's about 40,000 Jamaican dollars. So if you plan to ship that through a freight forwarding company, you'll have to take note of the weight of the inverter and also the GCT that you'll pay and the shipping charges that the freight forwarding companies will charge. For the battery cells, I basically paid about $62 per cell, so that would cost roughly 500 US dollars for all 8, and they weigh about 12 pounds, so you can do the math. The BMS along with the screen of the BMS, that cost about 90 US dollars. The cost of all the wiring was about 60 US dollars, but what I did, I basically bought the exact length of wiring that I needed. The cost of the breakers, all 4 breakers, along with the 2 outlets that you saw below the breakers, cost about 70 US dollars. And all the other little items like the DIN rail that I used to mount the breakers on, as well as the outlet, the little clips that I use, screws that I use, zip ties and so on, all of those came to around 40 US dollars. So you're looking at about a grand total of 1,000 US dollars, or in at the current Jamaican exchange rate, you're looking at about $165,000 thereabout. Yeah, so that's what a system like this will cost. There were some other costs such as tools and so on that I had before, so I didn't really add those to the cost of the project. So you also need to bear that in mind if you are planning on building something like this. So yeah, I think that's basically it. I know I didn't cover everything, but it's a work in progress. This channel is pretty new. This YouTube thing is also a bit new to me, so hope you can give me some feedback. Good, bad feedback is important for the growth of the channel right now, so whatever feedback you guys can provide, just drop it in the comment section below. And thank you for listening, thank you for watching. That's it.